Today we're going to look at Chapter 25, Section 3, Area Under a Curve. So recall from before that the integral from a to b of f prime of x dx is the area under the curve f prime of x from x equals a to x equals b, and that's equal to f of b minus f of a. So remember, it's the integral of f prime, and then it's the function f of b minus f of a. So we're going to do a couple examples. And remember that this is basically just the definite integral that we did last class. It's just with a different type of situation attached to it. So for our first example, it says find the area under the curve y equals 2x from 0 to 4. So here is a graph of my function y equals 2x, and I've highlighted the area that's under the curve from x equals 0 to x equals 4. So this is graphically what we're trying to find, the area shaded in yellow. And what we do is we set up the integral from 0 to 4, 2x dx. By rules of integration, the integral of 2x is x squared. Remember, we don't need the plus c like we do in the indefinite integral because it's going to go away when we do the subtraction. So it's just x squared evaluated from 0 to 4. So when we plug in 4, we get 16. When we plug in 0, we get 0. So it's 16 minus 0, and that is, of course, 16. For our next example, we have find the area under the curve y equals 1 minus x squared from negative 1 to 1. So again, I have a graph of it here for you. Shaded in yellow is the area under the curve from negative 1 to 1. And we set up the integral. The integral from negative 1 to 1 of 1 minus x squared dx. We integrate 1 and we get x. We integrate x squared and we get 1/3 x cubed. And again, this is being evaluated from negative 1 to 1. When I plug in 1, I get 1 minus 1/3. And then in parentheses, I have when I plug in negative 1. So negative 1 plus 1/3. We'll have a double negative, it becomes a positive. And then 1 minus 1/3 is 2/3. And inside the parentheses, negative 1 plus 1/3 is negative 2/3. And again, we get that double negative. So we have 2/3 plus 2/3. And that gives us 4/3. And it's not a coincidence that we had 2/3 and 2/3. Because if we look back at our picture, we can see that this area is equal to this area. So each of those areas is that 2/3. So again, in total, we have 4/3. For our next example, it says find the area under y equals x squared from 0 to 3. And again, we have a picture here for you. So here's the graph of y equals x squared shaded below the graph from 0 to 3. In integral form, that is the integral from 0 to 3 of x squared dx. And again, the integral of x squared is 1/3 x cubed, like we just had from the last example. And it's evaluated from 0 to 3. If I plug in 3, I have 1/3 of 3 cubed. That's 1/3 of 27, which is 9. And then plugging in 0, I get 0. And 9 minus 0 is 9. So that whole area is 9 units squared, right, whatever the units of y and x are. So for our last example, we have find the area under the curve x divided by the cubed root of x squared minus 4, all plus 2, from negative 1 to positive 1. So I have a picture of my curve here. We've got, again, it highlighted from negative 1 to 1. And setting up the integral, we have the integral from negative 1 to 1 of our whole function dx. To integrate this guy, we're going to need U-substitution. So we have the cubed root of x squared minus 4, so that's a function being raised to a power. So we want u to be that function. So u is x squared minus 4. And then we differentiate and get du equals 2x dx. Again, you can think of this as du dx equals 2x, and then multiply both sides by the dx. If we ignore the plus 2 for now, we just look at the integral of x divided by the cubed root of x squared minus 4, we plug in our u-substitution, we get 1/2 the integral of u to the negative 1/3 du. So I'm rewriting 1 over the cubed root as to the negative 1/3, and then this 1/2 is coming from dividing this guy by the 2. So that is then 3/4 u to the 2/3 after integrating. So putting it all together, we have 3/4 x squared minus 4 to the 2/3 plus 2x when we integrate the 2. And then everything is from negative 1 to 1. Plugging in our negative 1, plugging in 1, we get 3/4 the cubed root of 9 plus 2. And plugging in negative 1, we get 3/4 the cubed root of 9 minus 2. And when we simplify this, those cube roots of 9 end up canceling, and we're left with 2 minus negative 2, which is 4. Okay, so if you have any questions, let me know. Otherwise, try out the homework and let's see how it goes.